Welcome. Welcome to our channel. Today we're going to look at differentiating using first principles, and we've got an equation um, that specify that the limit of a function uh, when h is approaching 0 of f of x plus h minus f of x all over h is equivalent to the gradient today. So m is the gradient. So that is the gradient. So when you look at the gradient, um, typically this is a gradient of a tangent, and then h is the change in x. So our h is change in x, and then we're going to apply the formula for calculating the limit. Okay, so let's start with a straightforward, easy question. Let's say we're given this equation, given that we have y is equals to x squared plus, let's make it 2. So y is equals to x squared plus 2 is given to us, and we need to find the tangent to this equation. So utilizing the first principles, so we have m is equals to the limit when h is approaching 0 of the function f of x plus h minus f of x divided by our h. We are first required to okay, so it's not really a requirement, but I would suggest that since y is given in terms of x, we need to replace, so y is f of x is given as x squared plus 2. We need to find what is f of x plus our h. So wherever we see x, we're going to replace it plus h like that, plus our constant 2, and we're going to simplify this. So it's x plus h plus 2, which gives us x squared plus 2xh plus h plus 2. So that's our f of x plus h, meaning that we're going to plug it in there. So when we plug it in there, we have the limit when h is approaching 0. Our f of x plus h is this one. So we've got x squared plus the 2xh plus the h squared. Forgot about that, h squared. Pardon me. Plus our 2. This function is subtracted to f of x plus h. So our f of x plus h is x squared plus 2 divided by h. So this will give us the limit as h approaches 0, and we have x squared plus 2xh plus h squared plus 2 minus x squared minus 2 all over the function h. So that's x squared, and that x squared will cancel. That positive 2 and that negative 2 will cancel. And we have the limit as h approaches 0 of 2xh plus h squared over h. At this point, if we are now required to substitute h with 0, we will get to a point where it's undesirable because we'll get a 0 over a 0, which ultimately is not what we want. What we are looking for is to find the exact value. So we will factorize the numerator. So removing h as a common factor, we'll have 2x plus h over h. And this will cancel that one out. Then we can substitute h with 0. We'll have 2x plus 0, which will give us the gradient is 2x. So remember, this one is not desired. So that one is not something we're going to go for, because it's going to give us an answer of 0 over 0, which is not desirable in our case. Okay, so that's the first real example. Let's look at another one where now we will be required to add a certain element to the question. Let's say we need to find the tangent to sorry, not the tangent. Let's find the gradient. Let's say find the gradient. Let's say find the gradient of the tangent. All right, to the curve of the following function. Let's say we've got y is given as 3x squared minus 4x plus 2 at let's give the point at the point 1 and 1. So here we're still going to find the gradient using the first principles, and we're going to find also the gradient of the tangent. So we need to find the gradient of the tangent to the curve, and we are given a specific point at 1 and 1. So same story. So this is actually f of x, which is 3x squared minus 4x plus 2. And then f of x plus our h will be forcing us to get what? 3 into, so this is x plus h squared minus 4 into x plus h plus our 2. Then we can expand this, but we know that we have x squared plus 2xh plus h squared minus 4x minus 4h plus our 2, and that will give us 3x squared plus 6xh plus 3h squared minus 4x minus 4h plus 2. Okay, so that's a bit of a mouthful, but anyway, that's gonna sort us out. So now we first get the gradient, which is the limit when h is approaching 0 of a function f of x plus h minus f of x divided by h. And then we're going to plug in our values. So we already established what is f of x plus h. That is 3x squared plus 6xh plus 3h squared minus 4x minus 4h plus 2. This is subtracted to the following: 3x squared minus 4x plus 2. The entire thing is divided by h. So that will be the limit as h approaches 0. So we have 3x squared plus 6xh plus 3h squared minus 4x minus 4h plus 2 minus 3x squared plus 4x minus 2 all over h. Okay, so 3x squared minus 3x squared will cancel, and then we have minus 4x with plus 4x cancelling. Positive 2 will cancel with negative 2. Okie dokie, so that will lead us to the limit as h approaches 0. We have 6xh plus 3h squared minus 4h divided by h. And we'll be forced to take out h as a common factor. Then we're left with 6x plus 3h minus 4 divided by h. Then h will cancel with another h. Just go down a bit, and we'll have the limit as h approaches 0 of 6x plus 3h minus 4. And when we substitute h with 0, we'll have 6x minus 4, which is our gradient. Okie dokie. So the second part, where we've got a point, therefore the gradient of the tangent at a point 1 and 1 will give us the gradient is 6x minus 4, which we can substitute our value of x as 1 minus 4, and our gradient will be equals to 2. I hope you find that very, very, very helpful. quite a mouthful, but these are two critically important questions. Please like, subscribe, and comment on our videos. That will help us to create more content. Hope to see you in another video. Thank you. Bye bye.